This tutorial will introduce you to the mass properties and Aero reference options under the Geom menu on the main menu toolbar. Let's add a pod and an MS wing. The first step is to specify the density of the part in the Transform tab. Remember that density is the ratio of mass to volume. If you set the density to 0, you can then select a thin shell geometry. The ratio that governs this is the shell mass to surface area. This is particularly useful for when modeling commercial airline fuselages. You may have also noticed that there are no units labeled in VSP. Since VSP is specifically a parametric geometry modeler, all the dimensions are relative to the 0 points of the model. It is up to the user to keep consistent units throughout the design process, whether they are metric or English units. For this example, let's select a density of 5 for the wing and the pod. Now go to Geom on the main menu toolbar and select Mass Properties. On the Mass Properties browser, next to Num Slice, you can specify the number of slices you want to make in your model. Selecting more slices will yield more accurate results. Draw CG will place a graphical center of gravity on the model in the window. Select that, then click Compute. VSP will output a mesh of the slices generated, and it will display the calculated results for the centers of gravity, the moments of inertia, and the cross products of the moments of inertia of your model. The total mass shown here is affected by the specified density of the model, which was done earlier in the Transform tab. Another analysis tool is the Aero reference option under Geom. This will calculate the mean aerodynamic chord for the wing and display the aerodynamic center of the model, which is shown in blue. The graphical representation of the center of gravity is designated by black. For this browser, you also have the option of inputting values for the various parameters. Use the drop-down menu to select User. Change the parameter, then hit Enter. You can see that the graphical representation's updated in the main window. If you select Auto, the value will adjust back to the predetermined parameter. For the center of gravity parameters, the values in the Aero reference browser need to match the ones from the Mass Properties browser. Otherwise, the calculations for the static margin will not be correct. If this is not the case, for example, let's say this is 14, then you should remove the mesh, close these browsers, have these shown, and recalculate the mass properties. Then you can reopen Aero reference. The center of gravity should now match up. You can also specify which part you are looking at. For example, if you select Pod, then these top two sections will update, but the center of gravities will remain the same. This completes your introduction to the Mass Properties option and the Aero reference option. Let's review what you have learned. You were introduced to the concept of assigning a density to specific parts. Using those densities, you calculated various mass properties of your aircraft. You were also introduced to the Aero reference browser and computed aerodynamic parameters.